Okay, so we will continue with explanation about the chemical bond. In this example, for each of the following atoms, explain how each atom will attain stability or to become stable. For an atom to become stable, and it either satisfy octet rule or satisfy duet rule. Satisfy octet rule, and it must have 8 electrons in outer energy level, and duet rule, it must be saturated by 2 electrons or a completed the last energy level must be completed by 2 electrons. In order to determine what is the valence or how lithium atom become stable, will return back to its electron configuration in order to know what is the column of each atom. Let's remember that any element of column 1, it will lose 1 electron in order to be stable. For any element in column 2 and 13, they will lose 2 electrons or lose 3 electrons for the elements of column 13. If we look at the electron configuration of lithium, lithium has 1 valence electron, so it is in column 1. Column 1, so it will lose this valence electron. When it loses this valence electron, so the energy level is completed by 2 electrons, satisfies the duet rule. For carbon atom has a valence electron is equal to 4, so it is in column 14. Any element of column 14 will need more 4 electrons, will need another 4 electrons in order to be stable. If we add to it another 4 electrons, the last energy level will become saturated by 8. So the carbon atom will satisfy the octet rule in order to become stable. Let's turn back to the example for lithium atom. Lithium atom, since it is K2L1, so it lose 1 electron to be stable. Carbon has K2L4, it is in column 14. Column 14, so it will need 4 electrons in order to be stable or to become a has or satisfy the octet. So satisfy the octet rule. When it satisfies the octet rule, this energy level will become, after adding more 4 electrons, K2L8, so the outer energy is completed by 8 electrons. Oxygen, which is 8, has an electron configuration K2L6, so it needs 2 more electrons to be stable or satisfying the octet rule. For hydrogen, hydrogen 1 has K1, so it needs another 1 electron in order to become a saturated, to have a saturated energy level K, so it needs 1 electron to be stable. Here hydrogen obey the duet rule since it will have energy level K2 is filled with 2 electrons. Magnesium 12 K2 L8 M2, it is in column 2. It has 2 valence electrons, so any element in column 2 will lose 2 electrons to be stable and obey the octet rule. When it obeys the octet rule, the electron configuration will become K2L8, so we have an 8 electrons in outer energy level, and so on. For helium, Helium He2 has a K2, so it is a stable element. It stable element neither lose or gain electrons or doesn't need any electrons in order to become stable. It's already stable since have a complete energy level or a saturated energy level K2. For aluminum هي K2L8M3, it is in column 13, holds 3 valence electrons, so loses 3 electrons to be stable, satisfying the octet rule. Satisfying the octet rules, we have an energy level K2L8 by losing these three electrons, so it will have a complete energy level by K2 and L8. For phosphorus P15, K2, L8 and 5. Column, it is in column 15. Column 15, so it needs 3 more electrons to satisfy the octet rule and become stable element or stable octet rule. Okay. For the element fluorine, fluorine has an atomic number 9, the electron configuration K2L7. Since it has a 7 valence electron, so it needs 1 electron in order to be stable or satisfying the octet rule. Neon Ne10, the electron configuration is K2L8. The energy level are filled with electrons, with the maximum electron for K level by 2 electrons and L with 8 electrons, so it is an unstable element, so it doesn't need or lose any electron in order to become stable. It is already a stable element. Chlorine has a valence electron with 7 valence electrons, so it needs 1 electron in order to be stable.